Thanks for stopping by. We are really glad we have some audience, so thank you a lot. My name is Jaroslav Tulach, and I work on NetBeans. And together with me, this is Tomáš Stupka. He is working on NetBeans as well, and he is responsible for Mylyn integration. And Stefan Pingle is from Tasktop, the company behind Mylyn, and he's basically helping us integrate Mylyn into NetBeans. So Stefan, it's your turn. Tell us about Mylyn.
Yeah, thank you. I thought you were helping us to evolve Mylyn. So I'm a committer on the Mylyn project, and I work for Tasktop Technologies, which is the company behind the Eclipse Mylyn project. And we want to take you sort of through the process how NetBeans ended up with Mylyn support. And we're going to start looking at Mylyn, looking a bit at the history of Mylyn, to see where Mylyn is actually coming from and how these APIs in Mylyn evolved that NetBeans is using. And then look at NetBeans and how NetBeans is consuming those APIs. And then Tomáš will show a demo of how that's working now. And we'll go over the lessons learned from that experience. So around a decade ago, Mick Kirsten, the founder of the Mylyn project, was working on AspectJ. And that was around the time when Kent Beck published his book. And the AspectJ project was following the principles, the Agile development process described in this book. And in that project, they were using Outlook for project communication. They had some defects in Bugzilla. They had Microsoft SharePoint for managing their stories. And their day-to-day work was happening in the Eclipse IDE. So what Mick noticed at the time is that there was a lack of integration. Even though all these different systems were important for the project, they weren't integrated with the tools that developers were using day to day. So that was sort of Mick's first motivation to think about the Mylyn project. And Mick looked at the IDE in a little more detail, and what he noticed is that the IDE is very good at showing you the compiler-centric structure of the system. So the typical IDE has a couple dozen projects, has thousands of classes, and you get instant access to all these different artifacts in your system. But when you're fixing a particular defect, or if you're working on a particular feature, usually you only really care about a handful of classes that are relevant for that task at hand that you're working on. But this IDE shows you the entire system, so it overloads you with information. And this what we call the task context, these number of artifacts that are relevant to your task at hand, you lose that context every time you multitask. So every time you switch to a different task, you lose that context, and when you go back, you have to rebuild that in your memory. And that was Mick's motivation to build what we call the task-focused interface. And that task-focused interface, what it provides you is it filters everything from the IDE that's not part of the task context, and it monitors your interactions to automatically create that task context. And at the time, that was around 2004, while Mick was doing his PhD at the University of British Columbia, this task-focused interface was basically an idea on a whiteboard. And what was very clear already at the time is that in order to enable this task-focused interface, the tasks had to become a first-class part of the IDE. So Mick started working on this as part of his PhD and created a project which was called Modular at the time at Eclipse. At the time it was an Eclipse technology project, and to bring those tasks that already existed in Bugzilla and Jira and other issue tracking systems into Eclipse, Mick started by creating an integration for Bugzilla, because that at the time was what Eclipse org was using and is still using to track all the all the defects and tasks. So in that initial version that Mick put on Eclipse, the Mylyn project had a Bugzilla connector. And the second connector that Mick created was one for Jira that allowed people to access their Jira tasks from Eclipse. And at that time, there was already a little bit of abstraction. So they looked at what's common between Bugzilla and Jira and started creating what has become the task framework. So a little bit of abstraction that for the common API concerns. And that was around the time when I joined the Mylyn project doing my Summer of Code project for Google. I developed a track connector that built on that common abstraction that they had created. And over time, that Mylyn project turned into Mylyn, was added to a lot of the EPP packages, which you can now download from Eclipse.org. So most of the time when you get a download from Eclipse.org, that will already include Mylyn. And eventually, the project started expanding its scope from just tasks to also code reviews and builds in Hudson and Jenkins. And we decided to create a top-level project and split these different concerns into sub-projects. So the Mylyn project is now 6 or 8 different projects that cover concerns of the application lifecycle. The task integration does the Bugzilla, Track, Jira, and so on integration, and there's builds and reviews for these new concerns. And what's really interesting is that each of these sub-projects has a framework component, and it has several reference implementations that implement the framework. And the framework component provides the generic API to access tasks or builds or reviews, and then the different extensions, connectors, provide access to specific systems. These are the ones that are part of the Eclipse Mylyn project. And beyond that, there's a huge ecosystem of some commercially available connectors, some open source connectors that are developed outside of Eclipse.org that build on that very same framework that we created. And looking at this on a technical level, each of these framework modules or connector extensions is essentially a plugin in Eclipse. And all of these plugins run in a common runtime, which is called Equinox. And Equinox implements OSGi. So in Equinox, these plugins are called bundles, just a different term. And each of these bundles defines in its manifests which other bundles it depends on and which packages, Java packages it exports, which is its API that other bundles can consume. This chart shows the transitive dependencies of the Bugzilla core. So that's basically the core portion of the connector that is also consumed by NetBeans. And so you can see there's, I don't know, maybe 20, 25 different modules that you need to consume that Bugzilla integration. And this works really well because all of these modules follow a very strict API contract. So, Mylyn 3.8 is backwards compatible all the way to Mylyn 3.0, which was released 3-4 years ago. So any extension that you develop for Mylyn 3.0 will still work in Mylyn 3.8. And that's because the way that we evolve the APIs follows a very strict contract. So we always maintain that backwards compatibility. And what's really interesting to me is that because we had this modularity in mind initially when we developed the task-focused interface, setting out for a completely different goal than doing a NetBeans integration, we were still able now to satisfy a completely different and completely new use case building on top of the frameworks, even though we had something completely different in mind when we started the project. And that's possible through through those strict versioning constraints and through those strict API contracts. And looking at the task framework in particular, which is what NetBeans uses, it basically looks like this. So there's a framework component that defines a service provider interface. And that service provider interface is consumed by integrators that build connectors. And connectors understand how they can connect to a specific task repository like Bugzilla or Jira Track. They typically go over a REST interface or a SOAP interface, XML RPC or something like that. And they understand the domain model of that particular task repository and provide a mapping to a generic task data model that's defined in the tasks framework. And the task framework provides services like an offline store. So the connector gets a task from Bugzilla, translated to the generic data model, and then the task framework will handle persistence in the offline store, for example. And the task framework component also exposes an API. And that API is what's consumed by the Eclipse UI, and is also now consumed by NetBeans. And what's really neat about this is that since NetBeans only couples to the API part of it, in theory, you get all the extensions for free. Since the entire framework part has a generic data model that's agnostic to whatever the connector is doing, NetBeans can simply consume the Mylyn API and then leverage that whole ecosystem of connectors that's already out there, in theory. And that task model is basically a DOM that has a generic attribute scheme and provides some metadata for the different attributes that are part of a task. You get a label, you get a type, and so on. And it's even possible to generate generic UIs based on that meta model. And I'll hand over to you now to show us how that works in NetBeans.
Thank you, Stefan. So first thing I'd like to start is talk a bit about NetBeans history, because from describing the history, it should be apparent why we decided to support OSGi. NetBeans started as a student project in Czech Republic, and I was one of the students that participated in it. We basically, originally, we wanted to create a Delphi for X Windows and wrote that in C++. But, you know, student projects. We were meeting every week and discussing the design and then going to pub and doing that for almost a year, and we did nothing. After a year, I suggested, well, there is a new programming language, Java. Shouldn't we try that? Because I had experience with Java from some other project. And other students said, oh, no way, no way. So for next 3 months, we were meeting and still doing nothing or progressing nowhere. But after 3 months, I proposed to use Java again, and at the end, we decided to really write IDE in Java. We successfully finished the project. Certain people say that it was because no teacher at Charles University knew how to compile and execute Java, so people couldn't play with it. And of course, when we did the demo, we know what to try and what to avoid. So we successfully finished the project, and then we decided to sell. At that time, it was called Delphi as a shareware. We haven't earned much money, but we attracted attention of a Czech entrepreneur who was leading Sybase for Central Europe. But he didn't like the job and wanted to start a startup and was looking for good programmers. So he found us, and we created a company which later became NetBeans in 1997. In 1999, we were acquired by Sun Microsystems, And the first thing Sun basically did was that it decided that NetBeans should be open source. So in the middle of year 2000, we became an open source project. So right now, since then, we are working in the open source space. We are Swing-based IDE for various technologies, and we have actually 1.2 million of active users that use the IDE at least twice a month. Also, I was the original architect of the NetBeans IDE, and actually, I didn't want to design IDE. I wanted to design a platform for generic applications, but we couldn't find a business use case for that. So basically, we needed to create the IDE for a living, but the goal behind, or my goal behind, was to design a platform that you can use for any kind of application, something similar to Eclipse RCP. So we have it. Part of the platform was also a modular system. It's a homemade modular system, which we developed in course of the years. And it is very similar to OSGi. It stores additional information about exported packages. We call it public packages. In manifest, it stores dependencies between different modules in manifests. Sort of similar system. Now, let's jump into year 2009. At that time, I guess it was in April, we learned that Sun is close to collapse, and that Jonathan Schwartz, our former CEO, is negotiating with IBM to buy us. And the team in Prague working on NetBeans freaked out because IBM's pet is Eclipse, and we would very likely not survive at all. So we were really pleased that after 2 weeks, it turned out that we are going to be acquired by Oracle. Because we didn't know what are the Oracle plans, but at least we thought we can get a chance. So we will not be killed immediately when we are acquired. But this was in April 2009, and it took 1.5 years before we actually became part of Oracle, at least in Prague. And you can probably imagine that the team was not certain about future. People were depressed. Nobody wanted to work. So it was really a tough period of time. Because we knew that Oracle has its own IDE, JDeveloper. We knew that it supports Eclipse. And now it will also own NetBeans. So it's good. I'm actually glad I can work for Oracle, because after working 10 years for Sun, I'm glad I can finally work for a profitable company. But even a profitable company like Oracle cannot probably sponsor 3 projects doing the same thing for an unlimited amount of time. So I got an idea that basically we probably cannot convince JDeveloper to be rewritten on top of NetBeans platform. But I said, okay, maybe we could convince them to rewrite to OSGi, and then make sure that NetBeans supports OSGi as well, and somehow we could then merge those projects slowly. So I convinced our management that the main theme for NetBeans 6.9 should be OSGi interoperability. And we were not using the OSGi in NetBeans for our purposes at that time. We just wanted to offer the NetBeans platform users an ability to use OSGi. One of the use cases that we described was interoperability with your web server. For example, if you have a form in your rich client application, you need to perform a validation. for that, you may need a module that does the validation. But the same module needs to run on your Glassfish server, because as soon as the data are submitted, they need to be verified by the server as well. So that was one of the use cases. The other thing was to reuse existing APIs bundled as OSGi bundles seamlessly in NetBeans. So the picture on the right side basically shows how the system inside of NetBeans looks like. So we are still keeping our module system and dependencies between modules, but next to it, we can also run OSGi container. At that time, we were supporting Felix. Of course, these two words can live next to each other basically without any problems. The only complication is when you want an OSGi bundle to talk to APIs from NetBeans module, or if you want a NetBeans module to talk to APIs coming from OSGi bundle. So for that, I needed to patch Felix. Well, actually, my first version was heavily dependent on a reflection. I was just messing with internal structures of Felix to convince Felix to load classes for a bundle from NetBeans module. Basically, if you know OSGi, there is a support for boot delegation. So each bundle can basically say that certain classes should be loaded from a class application class loader, from the boot class path, basically. So I was reusing this. I just needed to. So I set for all the. Yeah. So basically, I'm creating fake OSGi bundle, which is completely empty, for each NetBeans module that needs to be consumed by the OSGi, by real OSGi bundles. And I'm changing its boot delegation class loader to be the class loader of the NetBeans module. So basically, whenever someone needs to load something from the OSGi bundle, it finds nothing, but then it delegates to the NetBeans module system, and the real class is loaded by NetBeans. And I'm doing similar thing for the NetBeans side, which was easier because I controlled the code base. But at the end, I managed to submit a patch to Richard Hall, the maintainer of Felix. So right now we have a proprietary API between NetBeans and Felix to hook in the different class loaders for boot delegation, different class loader for each bundle. Okay, so basically that was the public plan. Support OSGi, allow you to share bundles on your client as well on the server. But the hidden agenda was we can hopefully align with JDeveloper. So I guess it was in the middle of 2010 when finally the OSGi guys, the Oracle guys started to talk to us. Before that, there was no sign of communication whatsoever. So we could only guess whether we are doing the right thing. And it turned out that the JDeveloper guys were watching what we do with OSGi. And meanwhile, they rewrote JDeveloper to use OSGi. So I was originally expected that it will take years to convert JDeveloper to OSGi. But then suddenly we were acquired and the work has been done. It had just one problem. JDeveloper guys decided to use Equinox. So I needed to integrate NetBeans also with Equinox. And surprisingly, that was easier than integrating Felix, because actually I like to say that Equinox is not OSGi container. It's OSGi meta container. It has support for many hooks, and by implementing these hooks, you can basically change the behavior of Equinox and get something different. So there is a class loading hook, which I implemented to basically load the classes from the NetBeans module, and I could use official Equinox API. I didn't have to do the dirty tricks like in case of Felix. So the only problem was how to convince the JDeveloper guys to not use plain Equinox, but use the mixture of NetBeans platform together with Equinox. And I call it Netbinox. So I decided I will try to convince them by saying, if you switch to NetBeans platform with Netbinox, you will be much faster. So they gave me a time to really prove that. So after probably a half a year of coding, I managed to really start JDeveloper about 30% faster than it starts with plain Equinox. And the trick I did is we have in NetBeans, we have startup caches. On a first start of NetBeans, we basically load every class from its appropriate module. But we record what classes are needed during start, and we store them into one huge file. It has about 30 megabytes. And on the next start, we just verify that nothing changed in the configuration, and then load this huge file. And we are not opening the jar files at all. So instead of doing a huge amount of I/O, we are basically loading things in one go. We load all the classes. And the result is 40% better startup for JDeveloper. So JDeveloper was famous for having really slow startup. By switching to OSGi, guys managed to improve their startup. So it started in 1 minute. If you basically, I'm describing the case when you shut your computer down, boot it on, and then launch JDeveloper or NetBeans, because that's the most I/O intensive start. So JDeveloper could start in 1 minute. When we switched to Netbinox, we were able to start in 40 seconds or something like that. So basically, since then, we have a common ground between NetBeans and JDeveloper, and we are starting to reusing more stuff. I cannot talk about it because there is the nasty slide that we shouldn't promise any future releases and stuff like that. So, but we are reusing more from NetBeans. But at the same time, we just said, okay, why not? Why reuse just between JDeveloper and NetBeans? Can't we reuse something with Eclipse? And the primary project that we were interested in was Mylyn. So originally, I guess we had Mylyn. We are using Mylyn since NetBeans 6.9. But at that time, because the OSGi support was still too young, and we did not support Equinox at that time, we were reusing Mylyn in a hacky way. Basically, we faked the OSGi environment, had our own implementation that always returned null and stuff like that. Tomáš is responsible for it. But of course, when we tried to upgrade to new version of Mylyn, we found out that the emulation is not good enough. We need to implement new methods. So we said, okay, let's do it properly. And we really turned, I guess, in NetBeans 7.1, or 7.0, I don't know. We started to really use Equinox and reuse Mylyn in its natural environment. So basically, when you saw the graph of dependencies for Bugzilla core, it contained about 25 Eclipse bundles. So those bundles are running under the hood of NetBeans as well. The perfect thing on Mylyn is that it separates UI and the core part of almost each connector or even the UI. So what we have in NetBeans, we are swing-based. So of course, we don't want to bring in SWT. But because Mylyn is well written, we can reuse just the core parts and then implement the IDE by ourselves. Implement the UI by ourselves. So this is what we did for the Bugzilla connector. and for the Gyre connector. This year I visited EclipseCon, and while being there, I could chat with Mylyn guys, and we said, okay, let's have a session at Java 1, what we are going to talk about, what we are going to demonstrate. So the plan was to demonstrate a generic connector. So basically, we would like to take track core from Eclipse and then generate the UI. Because the Mylyn contains meta information about the task model, we should be able to do it. So with that, it's probably Tomáš's turn to demonstrate that.
More slide. Okay. And am I on? Yeah, good. So like already mentioned, we already have 2 implementations of connectors in NetBeans, and that's namely Bugzilla and Jira, coincidentally the same that Mylyn started with. And with those 2, we actually, in the beginning, we decided to write our own UI, our own Swing UI, and that of course came with a lot of effort, because not only the whole coding had to be done, but also we were in the need to learn about Bugzilla and Jira internals, etc. And that's something, that's the question if that's the best idea how to do it, because we already have requests for 3 other connectors, highly voted in NetBeans, and the management isn't very happy about it. We always need a few months to come with something new or a new support. And during the time, like Jaroslav mentioned, we just learned from our tasktop colleagues that there is a possible other approach, just that there are already some metadata provided by the Mylyn API, by the task core API, which we could eventually try to use in being more generic and not going into hand coding every connector just from scratch, or the UI part of it. Now, while it's one thing if somebody tells you something like this on the phone, another thing is just to put your hands on it. So we decided to try out a prototype to evaluate it and to find out what it would mean in NetBeans as well, like in Eclipse. And now we are at the point that we have a working connector or working prototype, which already at its current stage makes it quite easy to set up a repository and to provide a rich task UI in which we are able to edit a task and we are able to invoke operations on a task while still being connector agnostic. We did this with a track core bundle, and actually at most of the places in our implementation we have no idea that it's track with which we deal there at the place. And that of course brings the most interesting thing of the whole story, and that's the integration into other IDE workflows. That's probably also why Mylyn is so popular, that it actually helps the users to automate and look up information they need currently at some context without having to switch between environments and look up files, etc. Well, on the other hand, we were already in the beginning told we knew it, and the fact is that some contracts and things are still missing. One of them is the repository metadata, which we would need to provide a query UI just to fill out all the fields with all the products and components, etc. While this might be something we eventually could be able to bypass somehow with a poor man's solution, there is another more vital problem, and that currently we don't have a generic way how to define a query at the repository and how to execute it against the connector. Now I would like to switch. And so still I would like to show you what we got, what's already working and what's as well as what's not working. So yeah, I would start with Eclipse. I have here a project, and what I do is that I just simply try to run it, and nothing happens besides the fact that I get an exception. And that's what we also encourage our users, just if you get an exception, so issue a task. So I create a task or a ticket. And I submit. Yeah, sorry, the server isn't running. At least we see that there is a real server running behind it. Okay. Did I create it? No. You can't help me. Yeah, it was working yesterday, and
Oh, we didn't
Could it be?
pray enough to the
we didn't
demo
pray
gods.
enough to the demo gods.
Oh dear, demo god.
No.
Help
Okay.
Tomáš to make
And
it work.
I was hoping that my Mylyn colleague would help me here. I'll try one more time just to create a task. Okay. Now this is the problem. Could it be because I'm not in a network? No. Okay.
Thank
Yeah,
you.
I'm running the server on a virtual box, but seems like that there is something with the networking setup. Okay, so we created the task, and now just let's leave Eclipse and switch to NetBeans, where let's say I'm a different user and I'm supposed to do something with the created task. So we got here a kind of a task dashboard, which currently contains no repositories, nothing. So I will start with creating a track repository, and obviously there is no connector available at the moment. So let's go to our plugin manager and check if there is any track plugin available. Well, no plugins at all. Doesn't matter anyway, we have none on the update center. So what I'm going to do right now, I've heard the other about that it's possible to reuse our OSGi bundles and Mylyn core connectors in NetBeans. And I know that there is one on my disk, and that's actually in the NetBeans or in the Eclipse install I just used a moment ago. So this is where I got the Eclipse installed. And here is a lot of OSGi bundles. And I'm going after the Mylyn track core one. Here. So I select it, and let's see what happens. And well, when I click on install, then the ID realizes that some dependencies aren't okay yet. So I have to look for something called Google JSON.
I was really impressed when I saw this. That
Okay.
even though it's an Eclipse plugin, NetBeans now realizes that there's a dependency missing.
Let's cross the fingers now, yeah.
Actually, that's because of OSGi.
Thanks to OSGi, actually.
We had to implement OSGi, and
Just to deal with the yeah, whatever. So now I should be okay, and okay, it seems to work. I click on next and continue, and it's running. This little delay has nothing to do with the fastest OSGi container in the world. It's actually here in the moment when we are installing the plugin. Unfortunately, it appears sometimes, sometimes not. We had no more time to get around it. So it's still true that JDEF is 40% faster.
I was talking about startup being faster.
I'm just trying to kill the time somehow.
Actually, I needed to implement API to bridge Eclipse registry into NetBeans way of registering things, and probably I have a little bug there. It's not.
This is still pretty cool because you don't need
to
restart NetBeans. It just works.
I was just about to show it. Thank you.
Whereas in Eclipse, you actually have to restart.
Well, so let's see how it works. Supposedly I installed it, so I tried to create the connector or the repository one more time, and here it is, track. So I need a name, and I need the URL. Come on. I need a username, and I need a password. And for example, compared to Bugzilla or the Jira repository setup, we are missing here a validate button. That's actually a little thing, but it's still missing in the Mylyn API. It's one of the things we find out that it's not there. This dialog here just doesn't know that it's dealing with track. It's just a generic Mylyn API object. It tries to provide with some data. Well, so we created a repository. Now we are able to create tasks or search for issues here. So let's try to find our null pointer. 5 more minutes. Okay, so I'll be a bit faster. Or one thing. This is actually a dialog which we kind of hacked. We had to patch track that at least a simple query, a simple kind of full text search is possible and works. But still, I'm able to search after summary, description, keywords. I'm also able to go after a specific ID, but in this case, it's not so thrilling. So let's run the query. And okay, I got one hit. I can save the query. And now it appears in the dashboard. I could create a category and add the issue, a kind of a folder under which I can store hand-picked issues. We plan for the future to add more flexible setups, like we got inspired by Mylyn. So, but okay, I opened the task, and this dialog here, like in the opposite to the query dialog, is actually completely fed only what we got through the task core API, which, yeah, the description could be maybe a bit bigger, but otherwise we have here a few typical or regular fields like status and reported and modified. Then we learned from the Mylyn API that we are provided with the information that there is a group of 6 components, of 6 attributes, which are default, and it's the component version, milestone, priority type, etc. And we generically just create a UI, but we decided to do this in 2 columns. But on the other hand, the user might have a wider screen, more space, so he can kind of custom it for himself. Then there are a few more fields or attributes which come from a logical group called people, is to whom it's assigned and who's on copy, etc. Well, now Jaroslav doesn't want to fix it, so I accept it.
Thank you.
Yeah. And, well, yeah. And for that, I used another logical group of attributes for creating the operations, and I used the accept operation. We don't know it is actually the accept operation. We just get the label, and we know that it is an option, etc. Everything from the track core connector. 1 more minute, 3 more minutes. Good. And, well, so I'll try to fix the issue now, but to do so, I need some sources, because I got no project open yet. So I will check it out from a Subversion repository, where actually the same project from Eclipse comes from. Let's say, yeah. And So checkout's running. Why today? Yeah, okay. And the IDE recognized that in the checkout there is also a project. No matter if it's an Eclipse project, I'm able to open it in NetBeans. I got here my sources. So let's evaluate the stack trace. And I see, okay, the null pointer probably comes from this variable here, or this member. So I'll check, okay, here it is initialized, and here, and this is probably the problem because there is, so I'll just fix it. I can add a comment to it. Oops. Yeah. And this is already where we actually don't do anything with the track core connector. We just fall back on what's already provided in NetBeans for like a task support. Well, I'm not going to commit it now. Let's say I will create a patch first. So I'm about to export the patch, and instead of saving it on a disk, opening it in a browser then, and trying to navigate through it from the browser, etc., I can directly attach it to an issue. And yeah, let's create a patch. And like we can see, it was automatically added to the issue, and I could save all the effort and time, and that's okay. At this point, I could show more things. We got commit hooks, we got more support for tasks. I could talk a bit more about what we plan for the future in means of the task-focused UI, but well, we are running out of time. So maybe just one more thing, that just with a little bit of more effort by implementers of connectors, we are actually able to provide quite more extra value and significant value for our users, and therefore it's also possible to provide that particular technology for our community so that it's embraced and adopted as well by NetBeans users. Thank you. And I've given the word to Yarda.
Great. Okay, so we'd like to continue with lessons learned. And Stefan can always jump in my talk and describe that it's not how I feel it is. It's much better. Definitely, I'd like to praise OSGi. It's a fantastic thing for interoperability. And it builds the common ground. And as soon as we basically start to reuse from the bottom, then it's just a matter of taking more stuff, satisfying all the dependencies, and things seem to work. We have a limit. We don't want to do SWT, but otherwise OSGi, perfect. Mylyn, flexible design. I wish the NetBeans modules had some such clear separation between UI and the core part. We don't have it. So reusing our modules inside of Eclipse probably would not be that easy. Some problems which I can describe is that Mylyn cannot run on top of Felix. So basically we had to implement the Equinox support. That's especially because the Eclipse libraries really require Equinox. And of course, nobody tried to run or use Felix outside of Eclipse before, definitely not in a other GUI environment. So that was a bit of challenge, but I think it's worth it. Metadata. Metadata are there, the intention is there, but basically all the connectors, as far as I am aware in Eclipse, have their own UI. So that means that the metadata are not good enough in most of the cases. So we would need some improvements to really reuse more than just a track. And even, for example, the query in the track had to be hacked around. This is a shameless plug. This week I'm going to publish a new book about API design. And actually, it talks about paradoxes. And I've noticed some of the paradoxes when talking with the Mylyn guys. So paradox 10 describes that in case you produce API, then maintaining code with API is simpler and easier than to maintain a code without an API. Because your users are programmers, they can program, and you can ask them, submit a patch. And this is exactly what Mylyn team does. Every time we needed something, they said, OK, create a patch, submit a bug. So we did it. It's a great open source cooperation, and that's exactly how I think APIs should be designed. Whoever has a need should be able to submit a patch. So that works very well. I would also like to mention paradox 18, which somehow says that there is a clash between reuse and use. If you want to reuse use certain API, then it's better to have it a monolithic. If you want to reuse it in a different environment, then actually more modularity, more granularity is better. So sometimes we would like if all the Mylyn bundles had less dependencies on other bundles, because then it would be easier to reuse them in NetBeans. For example, we were discussing about the registration of connectors. So right now it's reusing Eclipse extension registry. If it could be done in more OSGi-like way, it would be easier to reuse that. So right now, I think, or right now, as soon as we finish this project and put that into production, we should have an easy way how to reuse almost any Mylyn connector inside of NetBeans. We just need good connectors. We need people writing connectors to provide good enough metadata, don't write any UI, and really let the UI to be generated. Yeah, I've been told by David Green that you will have a TCK, or you have a TCK, and you will probably release it. So passing the TCK is definitely a good way how to ensure that your connector is good enough, even for NetBeans. So that's end of our talk. I think I should mention that OSGi, perfect for interoperability. Mylyn, we had a great cooperation. Don't be afraid to reuse Mylyn. Yeah, I think I'm probably known as the guy who shares between JDeveloper and now also Eclipse. So I would encourage you to share. It's good. Thank you. Do you have questions?
So is Equinox then going to be incorporated into NetBeans, or will it be part of like when you install Mylyn that would be
Wow. Can you ask once again?
well, you're using Equinox to power Mylyn on NetBeans.
Mm-hmm. Yeah.
So is Equinox going to become a standard part of the NetBeans release, or is it going to be just packaged with Mylyn to make power Mylyn?
Okay, so the question is whether Equinox will become standard part of NetBeans release. We first use Equinox for the JDeveloper guys. We convinced them to reuse or use Netbinox, the modified version, in their product. And a few months later, they ask, oh, you are not using this in NetBeans? Wow, that's strange. So we wanted to fix that. And right now, we are really reusing Equinox in NetBeans as well. Because we are running the Bugzilla connector in NetBeans already. It's part of the standard release. So Equinox is there. And when you are creating applications built on top of NetBeans platform, you can basically choose whether you want to create application with Felix or with Equinox. So yeah, it's already there.
You said that Eclipse registry was something from Tempus completely with OSGi services. Was there anything else you may?
Actually, that's the question was that I mentioned the Eclipse registry being a problem, whether we considered declarative services. Yes, we did consider declarative services. I even submitted a patch for Mylyn to allow the connectors to be registered with declarative services and make them available inside of Eclipse UI as well as NetBeans UI. And that's exactly the case because if the registration would be done by declarative services, we don't need the dependency on Eclipse registry at all, which would make the whole integration more lightweight. But Stefan will probably not apply my patch, but solve the issue slightly differently.
Well, I mean, just for historic reasons, we've been using the Eclipse extension registry for most of our extensibility. There's no reason why we wouldn't use OSGi services instead. But there's no reason to make that transition right now either. So that's a reason why we're not adopting that change right now. But I think for future services, we'll certainly use OSGi services.
Also, there was an issue because the declarative services worked very well for registering the connector. But the format in the extension registry allows you to also register converters or upgraders together with a connector. And that's not, I didn't know how to do it properly with declarative services. So the first version of the patch was really nice, slim, but not fully functional. And the new version is fully functional, but not nice. Any other question? Okay, so thanks for stopping by.